Hello, everyone, and welcome back to your channel of Engineering Made Easy. And we are still working with probability. Um, we looked at the joint probability distribution when we had random variables that are discrete. And today we are going to look what happens if they are continuous. So we can start by writing the equation. We can say that now um, f of x and y. So I think it's instead of summation, we are going to use integration. So we don't have to waste time. Let's start with an example. And this example is saying that suppose f of x and y equals some constant k, we don't know what it is, times x plus y square, where x and y are greater than 0, less than 1. And they tell you this example is about customers going into a bank. So they either go to the window or the drive-through. That's x and y. And they want to see what is the value of k. And you say, how do I know the value of k? Or do you know? Yes, you take the double integral because you know that if I integrate this function for x and y between 0 and 1, 0 and 1 of k times x plus y square, you can say dx dy or dy dx. It doesn't matter which one you start with since both are going from 0 to 1. But it seems like if we take the integral with respect to y to get so that we get rid of the square quickly, right? So we can say dy dx, that should equal 1, right? Because it's a valid probability, whether it's a regular probability or joint probability, when you integrate it, you should get 1. So we are going to look at the left-hand side. When you integrate with respect to y, you get xy plus y cubed over 3, evaluated between 0 and 1 dx, correct? So you get k. So the integral from 0 to 1. Of course, we are not going to substitute with 0 since 0 would make them 0 anyway. So subtracting 0 doesn't change anything. So when you substitute for y equals 1, you get x plus 1/3 dx. And when you integrate that, you get k times x squared over 2 plus 1/3 evaluated from 0 to 1 equals 1. So k times 1/2 plus 1/3 equals 1. You know how to add, of course, fractions if the numerator is constant, is the same number. When it's 1, it's easy. Numerator is the sum, the denominator is the product. So 1/2 plus 1/3 is 5/6, right? You know that. So 5/6k equals 1, or k equals 6/5. So now my f of x and y equals 6/5 x plus y squared, where x and y are both greater than or equal to 0, less than or equal to 1. Okay. 0 and 1 meaning the line are full or the line is empty. So we are okay. So now they ask you to the find the marginal distribution, marginal of x. We write it as fx of x. Okay? Meaning I'm going to integrate over all possible values of y. Remember when it was a tabular form and we said, what is the marginal of x? You say, I'm going to sum over all the columns, all the values of y, and see what x is, and I'm going to write it in the margin. So it's the same thing. The interesting thing here is that I'm going to say it's the integral from 0 to 1 of k, which is a constant, of x plus y squared dy. Okay, it's for dy when you because I'm summing over all possible values of y. But that's exactly what we did here, right? So there is no reason to repeat the work. I already have that without the integral. So if you exclude the integration and the dx and write this as 6/5, you will, or if you want, I mean, it's not a big deal. So 6/5 times xy plus y cubed over 3 evaluated from 0 to 1 equals 6 over 5 times, if y is 1, you get x plus 1/3. And you say for x between 0 and 1. That is the marginal of x, which if I integrate for x, I should get 1. That's what we did here, right? But if I want to find the mean of x, they didn't ask for that, but if they want the mean of x, it's the expected value of x. So I'm going to multiply this function by x and then integrate it from 0 to 1, and I will get a number. That would be the mean of x. Likewise, if I want to find the marginal of y, f y of y, I would integrate from 0 to 1, 6/5 of x plus y square dx. So you integrate with respect to x, and this is valid for y between 0 and 1. So you will get 6 over 5 times x squared over 2 plus xy squared, and the x is 1, so you get 6/5 times, well, y squared, if you want, plus 1/2, and y is between 0 and 1. Of course, you can distribute the 6/5 in both cases and write it as sum of two terms, but that's okay. Now, they ask you, what is the probability that you walk into a bank, you find that the inner queue is filled by 25%. So if there are space for 8 customers, there are only two, or if there are like 4 customers, there's only one. But on the outside, it's filled 3/4 of the way. And you say, oh, it's very full, so let me park and go, for example, inside. So what is the likelihood that, I'm not going to say that because that would be conditional. Given that the outside is filled 3/4, what is the likelihood that the inner would be less than a quarter, right? Do you see that? You don't know. But what is the probability that you go, you find outside is 3/4, and when you look inside, there's only one customer out of possible value of 4. Like this is 1/4, this is 3/4. So again, that's a double integration. So, and you would say, take the double integral. If x is outside, so I'm going to say x is going from 0 to a quarter and the y going from 0 to 3/4 of 6/5 x plus y squared. Notice this is the y, so I do dy dx. Okay, so we already did the dy. We kept going back to the same thing. It doesn't matter. So 6/5, the integral from 0 to a quarter of xy plus y cubed over 3 dx. And this is evaluated from 0. I'm sorry, this is 3. Oh yeah, I did the 3/4 here. It doesn't matter which is which. I mean, the problem can be here we are saying the x is 1/4, inside is 1/4, and outside is 3/4. I thought we were doing it backwards, so it doesn't matter. So this would be 6/5, the integral from 0 to 1/4 of. Now when I substitute y as 3/4, I get 3/4 x plus, and if this is 3/4, one of the 3 cubes, which is 27, is divided by 3, so I get 9 in the numerator, and the denominator is 4 cubed, which is 64 dx. Okay? So that's That's the thing I'm going to integrate. So I will get 6/5 times 3/8 x squared, right? Because I'm going to divide by 2, plus 9/64 x. And this is evaluated from 0 to a quarter. So I get 6/5 times 3/8 times a quarter square is 1/16 plus 9/64 times a quarter. This would be 6/5 3/128 plus 9/256, which is twice as that. So this can be written as 6/5. And then if I take 256 as a common denominator, that would be twice. So I get 2 times 3 is 6 plus 9 is 15. And now I can simplify this with that is 3. And this is 128. So you get the probability is 9/128. And you can do stuff like that very easily uh, because these, even though it's a combined function, but it's separable. The x is alone and the y square is alone. So maybe we can take another example, and this example is coming from divorce textbook. I wrote it down, and it says here, you have some kind of a vehicle that has two tires, one on the right, one on the left, and they can be filled between 20 and 30 psi. Okay, so if we call, say, the right x and the left y, x and y are greater than 20, less than 30 psi, but the spec says they should be filled at 26. Okay. And um, the function for them, f, x, and y, is given to you as k again times x squared plus y squared. So they ask you first to find the value of k. Second, to find the probability that both are underfilled, meaning they are going from 0 to 26. I'm sorry, from 20 to 26, but not 26, right? It's not so underfilled. Okay. And then finally, they want um, the uh, the marginal of the right tire, which should be the same because they are identical, right? And it's x squared, y squared, not like the previous problem. So really, it doesn't. I don't know why they asked the right, or they could have said either one. But anyway, so we check by taking the double integral from 20 to 30. I don't know, they will need a calculator here. X squared plus y squared. It doesn't matter which one we integrate with first, since both are squares. So if I start with the x, this would be k times the integral from 20 to 30 of x cubed over 3 plus xy squared evaluated from 20 to 30 dy equals k times the integral from 20 to 30 of, and then the way I always tell you to do, if the lower doesn't produce 0, is to have two pairs of parentheses with a negative sign between them, because you're going to evaluate at 30 here minus evaluating at 20 here. Notice only the x is 30. So if it's x is 30, we'll get 27,000. Remember, 3 squared is 27, over 3 is 9. So this is 9,000 minus 30y squared. And then you subtract from that 8,000 over 3, right? 20 cubed over 3 plus 20y squared dy equals k times the integral from 20 to 30 of, and this would be 27,000 over 3 minus 8 is 19,000 over 3 minus 30. Oh, I'm sorry, that's 30. Why did I say minus? I don't know. 30 minus 20, so plus 10 y squared dy. Okay, after that, you integrate and you equate to 1, of course, to solve for k. So that would become k times 19,000 y over 3 plus 10 y cubed over 3 from 20 to 30 equals 1. That, the left-hand side would give me k times. And then again, I'm going to do this to play it safe. So if this is 30, 30 over 3 is 10, so that would be 190,000 plus, if this is 30, again, 3 would cancel, so the 27,000 would be 9,000 times 10 is 90,000 minus, when I do 20, oh my God, this would be 380,000, right? If you multiply it by 2019 times 2 is 38, and you just add a 0 over 3 plus 20 cubed is 8,000. So this is 80,000 over 3. Okay, I don't know why they give us such horrible numbers. This is 570,000 minus this. So this is 190,000 over 3. Again, you could have used your calculator and you're waiting for me now, bored and growing your beards or okay, whatever. Plus 90,000 is 270,000 minus 80, so it's 190,000 over 3 again. Get the same number, right? Yeah, I think so. 3 times 90 is 270, and 270 minus 80 is 190, so it's 190,000. So really, you are getting 380,000 over 3. K equals 1. K equals 3 over 380,000. Wow. Took us like 5 minutes just to get K. That's terrible. Don't like that. Okay. So next, they ask you to find the marginal of, no, the probability that X and Y are greater than 20, of course, because they cannot be less than 20, but less than 26. I don't like that. I really don't know. Well, I think we will need to do it with a computer. That's a waste of time. We are going to say, okay, so let's keep the k. I'm not going to keep writing it. So it's k times the double integral from 20 to 26 of x squared plus y squared dx dy. So it's k times, this became like a calculus session, not I picked a wrong or a tough or a bad example. The integral from 20 to 26 of x cubed over 3 plus xy squared evaluated from 20 to 26 dy equals k times the integral from 20 to 26. I'm going to do this. And I need a calculator now because I'm going to do 26 cubed. And I don't know how to do that in my head. I'm horrible with that. I think I misplaced my calculator. I don't know. Thought it was, oh, no, I have it in the bag. So I was outside in a meeting and I needed it. Okay, so I get 26 cubed over 3 I'm not going to write that, right? Or so 26 cubed over 3. And then when I subtract, I would subtract 20 cubed over 3. So I get k times the integral from 20 to 26 of 3192 plus. And then here I have 26y squared minus 26 square minus 20y squared. So it's 6y squared dy, right? This is basically it. Now we can do this with a calculator. Let's do it with math and finite integration. I'm going to take the integral of 20 to 26 of 3192 plus 6x squared dx. And then when I get the result, I'm going to multiply it by 3 over 380,000, right? Because that should be multiplied by k times 3 over 380,000. It's 0.3024. Wow. I don't like that. And finally, they ask you to find the marginal of x, which is the integral from 20 to 30 of k. We know it's this, but I hate to keep writing, this large number of x squared plus y squared dy. Okay? And then you get k times x squared y plus y cubed over 3, evaluated from 20 to 30. So you get k times 30 x squared plus 9,000 minus 20x squared plus 8,000 over 3. So it's 10k times 10x squared, and this we said plus 100 or 19,000 over 3, right? We said this is 27, so 19,000 over 3. Of course, you would substitute in that for x greater than 20, less than 30. Okay, and that basically would be it to complete that chapter. The only thing I wanted to give you is maybe something we didn't do there, but I wanted to introduce the fact of the linear combination of random variables. I mentioned that before, but we never got the chance to take an example or to understand, because I want to tell you that um, throughout my teaching career, very early in it, I shouldn't say developed. I'm not like a mathematician or doing stuff, but I found an easy way for students who always had trouble when calculating a variance of a linear combination of random variables. I'll tell you exactly what I mean. Um, and I think I will show it through an example. So I made up some numbers here. So I said, suppose you have two random variables, x1 and x2, or let's call them x and y, it doesn't matter. So the expected value of x is given to you as 3, for example, and the variance of x is also 3. And the expected value of y, I made up that to be -2, and the variance of y is 5. Numbers don't make any sense, but suppose that's the case you have. In fact, I said also that you know that the expected value of x1 and x2, meaning x1 times no, x1, x2, not and. x1, x2. So when you multiply them and then multiply by the probability like we did the last time is -8. So here we want to find the expected value of x plus y and the variance of x plus y. The expected value of x plus y is so easy. It's linear, so you can break it into expected value of x plus expected value of y. Okay, that's even if I say, suppose you have another function that is 3 times x plus 4 times y, and you want its expected value, you would say, okay, so it's 3 times the expected value of x plus 4 times the expected value of y. It's very simple, extremely simple. Okay, so that's easy. That's 3 minus 2 equals 1. Okay, so the random variable x plus y, or the combination, this linear combination, equals 1. But how do I calculate the variance of x plus y? It turns out that it's not hard, but some students had trouble with it. So the way I said, or the way I devised, I say, every time you see the word variance, think square. Meaning, go to the side of the page and evaluate x plus y squared. You get x squared plus twice xy plus y squared. Okay? So the variance of x would be the variance would I'm going to go back now. I'm going to say it's the variance of x plus 2 times something I don't know plus the variance of y. X times y. Isn't that, if I call this variance and I call that variance, what should I call x times y? If you say covariance, you would be correct. That's how easy you find the variance. Again, after we're done, I'm going to show you something. But we haven't found the covariance. We knew that the covariance of x and y equals the expected value of xy minus the expected value of x times the expected value of y. So it equals -8 minus 3 times -2 equals -8 plus 6 equals -2. So now the variance of x and y equals the variance of x, which is 3, plus twice that, so meaning -4, plus the variance of y, which is 5. You get 5 plus 3 is 8 minus 4 is 4. Okay? So the variance of x and y is 4. Now, suppose we have, this is what I wanted to show you here. Suppose we have, if they are independent, by the way, if they are independent, we know that this line, so if independent, then the expected value of xy is 0, right? Or the covariance of x and y, I should say. The covariance of x and y would be 0. Meaning in this case, the expected value of xy uh, would have been -6, so that when I add them up, I get 0. Okay? So suppose I have a new variable z that equals 3x minus 2y. And I ask you, find the expected value of z and find the variance of z. Now, let's see now how easy it became. Well, I use the same numbers just by coincidence. Let's change that. Let's say z equals 4x minus y. Okay, and I want to find the expected value of that. So the expected value of z, that's the easiest thing. Every time you see a letter substituted by its expected value. So 4x, 4 times the expected value of x, minus y minus the expected value of y equals 4. Expected value of x is 3 minus the expected value of y is negative 2. So you get 12 plus 2 is 14. The mean of z is 14. And the variance of z, I would say, well, I don't know. I'm going to take this relationship 4x minus y and square it. 16x squared minus twice the first times the second, so minus 8xy plus the square of the second. See how easy it is? It's 16 times the variance of x, which is 3, minus 8 times the covariance of x and y, which is negative 2, plus the variance of y, which is 5. Notice this is the variance, not the standard deviation, so don't square it. I've seen students doing that. They square the 3 and the 5. No, that's the variance, not the standard deviation. If I gave you the standard deviation, you would, of course, square it. So you get 48 plus 16, that's 64, plus 5 is 69. If they ask you for the standard deviation, you take the square root of 69 and you get 8 point something. Okay, I hope this wasn't that bad, right? I I had students trouble for the first few years. I started teaching probability and statistics, but once I found this relationship between algebra and probability, it became much easier for them to get it right away. And I think, the students loved this problem in the test. The test, of course, was across board, so all the sections take the same exam, but they always did that, or the majority of them did that very well. I hope you do also better. Thank you very much for your time. Hope to see you soon.